Hey everybody, fun science video for you. So I have before you the love meter. Yeah, this weekend, by the way, it was Valentine's Day. I don't know if you realize that or not, but it was Valentine's Day, and I was on a trip with my lovely wife, and we had a nice Valentine's weekend. And one of the things that I thought I'd tell you about was that, well, my wife says that, I'm kind of hot. And I know a lot of you probably don't think that. So I got this fun little toy today that is called the love meter. And I thought I'd prove to you that I'm kind of hot because the love meter will show that. So here we go. Watch it. Here's the love meter. All right, and what we're going to see is, look, the liquid in there. Look, I'm so hot that it drove all the liquid up into that container. So this is a device that proves that I am actually kind of hot. I know a lot of you don't believe that. So actually, this is not really a love meter, but it is a pretty fun toy. And it's a pretty cool device. So what's actually going on? Well, first of all, in class, we've been talking a lot about three words. We've been talking a lot about the words radiation, convection, and conduction. And the first thing I want you to do is I want you to kind of pause the video and decide as a class if this is, which of those three is this? So go ahead and pause the video. Okay, we're back. And we just had a discussion in class, and hopefully you got this right along with the class. Hopefully you realize that this was conduction. And so why is this conduction, and what's actually going on here? So what's going on here is I've got heat on my hand, like I said, okay? And so when I touch this, okay, the heat from my hand is in direct contact with that liquid. And when my hand touches that liquid, two things start to happen with the particles in the liquid. One is those particles start to move a little bit faster, and they start to get a little bit further apart. And when they get a little bit further apart, as we learned earlier, they get a little less dense, but that's not what's actually making this go up. Okay, see, what's also happening is that this liquid that's in here, when I touch it, I turn some of those particles, get enough energy that they actually turn into a vapor. And so that makes the pressure inside of here. So there's a vapor inside of here, inside of this little container here. And the heat from my hand makes some of that liquid turn into a vapor, which makes the pressure go up. Now, also the heat from my hand makes those particles start to move faster that are in the vapor, and they are pounding into the sides of that glass more, which gives it a higher pressure, because more particles hitting the side of that container makes the pressure increase. All right. And so when that happens, the pressure increases, and that starts to push that liquid down, and there it forces then that liquid up this container. So when I touch this with my heat, higher pressure drives that up and forces it up. So what would happen if I touched it from the top? Well, if I touched it from the top, I would increase the pressure and it would go right back down to the other way. So I can increase the pressure down here. All right. Or I can increase the pressure up here. All right. So the next question would be, could I make this work a different way? Well, let's try that. Okay. Let's see if I can make this work a different way. So let's say that I just took some water, and I'm going to take some spray bottle water, and I'm just going to spray the top of this. I'm going to spray the top of this. Just give me a spurt here, one spray. Here we go. And look, it just came up as well. So what's going on with that? By the way, is this one radiation, convection, or conduction? Pause the video and let you try to decide that as a class. So pause it. Okay, we're back. Well, so this one, I had no direct contact at all. No direct contact at all. So this one must have been either radiation or convection. And the class decided, hopefully anyway, that this one was in fact radiation. So what's going on with this one? All right, why did it work when I didn't touch it? So this time what happened was something a little different. When I sprayed water here, okay, the water starts to evaporate. And in class, we learned that evaporation is either a warming or a cooling process. Let's pause the video and answer that real quick. Okay, I'm back. So evaporation is a cooling process. And so when the water starts to evaporate from that container, okay, what happens is it cools this. Well, the vapor that's cooled up here, some of that vapor, when it cools, starts to condense, and that makes the pressure up here lower. And so what happened in this case was the pressure didn't really change down here, but when I lowered the pressure up here, the higher pressure still was able to push it up, which is pretty darn cool. So that should mean, all right, that if I retouch up here now and make this warmer, it'll go right back down, and it will, which is pretty darn cool, all right? And so I could squeeze it again, and I could get it to go up with direct contact, which is conduction, or, okay, I could get it to go back down, all right? I could spray it with some water at the top, and that will cool as it evaporates, which lowers the pressure, and the high pressure pulls it back down. Now, if I were to spray down here at the bottom and let it start to evaporate down there, all right, now it's not really wanting to do that because I've got evaporation happening from both places. But if I put a little bit, if I dry that off up there, and I've got that, I can spray down there and it'll come down a lot quicker down there. So this one is radiation, all right? So radiation, sometimes I'll call that radiant energy also. So I have one other one that's kind of fun, and we'll decide if this one is either radiation, convection, or conduction. So let's bring over one more thing here. Okay, I've got some water here. And I've got this little bird here. And I'm going to bring this bird over. And I'm going to let you watch the bird for a second. I'm just going to get out of the way. And I'm going to try to make this a little bit easier for you to see by bringing this over here. Let's just kind of watch this. All right. So we have right here, again, we got this bird. And the bird looks like it's drinking, all right? This, by the way, was invented by a guy named Miles Sullivan. And when he invented this, this toy was a favorite of a former president named Herbert Hoover. And Herbert Hoover was an engineer before he became president. And Herbert Hoover loved this toy. Another guy who loved this toy was a guy named Albert Einstein. And Albert Einstein actually tried to figure this out without taking it apart, and he actually couldn't figure it out. It's kind of, there's Albert Einstein right there on the cover of that book. But he couldn't actually figure this out. And so how many people can say they stumped Einstein? Probably not very many. But what the heck is going on here with this? By the way, let's see something kind of cool about this. So I'm going to point to something right here. The head of that bird is got a felt on it. Okay? And that felt of that bird, okay, can absorb water. So what is that water starting to do? Well, that water is starting to evaporate. All right, so I wonder what happened though. Will the bird still drink if I move the water away? Let's watch him. Well, he looks like he's still going down and going back up. So what's the deal with that? Does the bird not really need the water? Well, the bird does actually need the water, see, but the bird will keep working as long as there's still water on that part of that head. The bird will keep working. And this bird will actually work a little bit over an hour in this room. It'll work a little over an hour as long as there's still some moisture on that head. So what's going on? Well, if you look here, what's actually going on is this is very, very similar. Oops, sorry. This is very, very similar to this device that we had, remember? So under that bird's hat is something that looks exactly like that. That's why the hat's actually there, to protect that little spot. And so what's going on here is it's very much working like the love meter worked when I didn't touch it. So the head has got water on it. The water's evaporating, which is cooling it. And when the water cools through evaporation, the pressure in the top of the head lowers. And so if you look over here at the bottom of that, you can kind of see there's a red liquid in it, and it's going up the neck. All right, and when it goes forward, watch, it's gonna let the liquid back in. And then you saw that liquid was actually lower than the red part of its neck for a little bit. And then it immediately kind of went back into the red part of his neck. So watch it again. When it tips forward here, you should be able to see this when it tips forward. So check it out. When it tips forward, you're going to watch that red liquid. It'll actually, right when it comes up, it's going to be lower than the red part of his head. Now it's not anymore. So you saw it. So what's happening is when it tips, some of the vapor from the bottom goes back to the head, which makes the pressures the same again. And the second that the pressure is the same, there starts to be some evaporation from the top of the head again, and that cools the top of the head, which now means that the bottom has a greater pressure, and that greater pressure starts to push the liquid up the neck of the bird. And once the neck gets high enough into the bird, it's going to make the birds have more weight by its head, and so the bird tips forward. And when the bird tips forward, the pressure equalizes again. You see some pressure coming from the bottom, and then the liquid has to be driven up again as it's doing it. And this bird is so incredibly cool. Science is so awesome. I don't know if you get that or not, but science is absolutely awesome. All right. And so this is an ingenious little toy. So which one is it? Is it convection? Is it radiation, or is it conduction? You decide real quick. I'm going to go ahead and put my camera back over here real quick while you're deciding that. Which one is it? All right. You hopefully are deciding which one it is. Hopefully being the opportune word. Hopefully you are deciding which one it is. Did you pick the right one? The drinking bird is completely radiation. And by the way, it just needs enough water for it to get going. Once it has enough water, it doesn't need more, but it'll keep drinking. If you put some water by it, it'll drink for a really long time, which is really, really cool. Science is awesome. By the way, one final little thought to ponder. I wonder if I used on the love meter, just one more thing for fun. What if I used some rubbing alcohol on the love meter? What if I used some rubbing alcohol? So let's move the drinking bird over here a little bit. Do you think if I put some rubbing alcohol on the top, would it go slower or faster? So think about that. Does the rubbing alcohol, when you put it on your body, does it evaporate slower or faster than water? Well, whichever one evaporates faster would mean it should cool the top faster. So let's just see how this works with alcohol on the top instead of water on the top. So let's just put some drops of the alcohol on the top and let's just watch it. And I don't know if you noticed that or not, but it actually went up faster with the alcohol than it did with the water, which is pretty darn cool. All right. Science is awesome. By the way, today, if you're watching this video today, I made this on February 17th, which is actually National Random Acts of Kindness Day. It's it's only 3 days after Valentine's Day. So you're supposed to show love to somebody randomly and show them an act of kindness. By the way, if you're a day late and you're watching this, you could still do a random act of kindness. In fact, if you're watching this and it's nowhere near February 17th, maybe you could still go out and do a random act of kindness. Science is awesome, but it's also awesome to show love and kindness to people around us. So hopefully you're having a great day. And science is awesome. Have a great one. Bye.